In the previous class, we have already started with this process control. This process control in this chapter, we are going to discuss completely about the process IDs and so many functions which are related to the process. So many functions like fork, vfork, execute function, exit functions, wait function, so many inbuilt functions where body is already been written and they are included in the header files. Uh, those functionality of those functions that we are going to discuss in this chapter. In the previous class, we have already discussed this process identifier. What is this process identifier is any process in the system, if it wants to be uniquely identified, if the in the system, if the process has to be uniquely identified, some address should be there. If you say that file name is there, that is not possible because in different locations in the system, you can give the same file name. Therefore, the file name is not unique. That is why that you cannot use it as a identifier for the process when that program is under execution. For that reason, what the operating system will do is it is going to generate a unique ID, a integer, which is a non-negative integer. Non-negative is nothing but its number starts from 0, 1, or any other number higher than that. One more thing, whether that number is the same number is given to the other process, no. When the process gets terminate, after some time, after some time means after so many process creation, or there are so many algorithms to delay the reuse of to delay the reuse of the process itself, because there may be a once again a problem by using the same process ID for the new process which we are going to create. That is why after some hours, 5 hours, 6 hours, or after so many process creation, they are going to reuse the same process IDs. 100% they are going to reuse the same process IDs. What operating system will do is what the file name is there, to that it is going to concat the process ID, and that will become a complete unique file name. Then it can be easily identified. Ah. See, this process IDs, 0 can be given to any of the process. No, it is not possible because that process ID by inbuilt in the operating system, it is been given to the scheduler process 0, and number 1 is given to the init process, and number 2 is given to the page domain. These numbers you cannot see. These process already been assigned. Other than these numbers can be given to the process which are gets generated in the system. Any number, some 500, 400, any number. If you want to check what is that number gets generated, for that you have to use this function. For that reason, operating system has already given you the uh, what inbuilt functions. Those inbuilt functions are this get PID, get PPID, get user ID, UID, effective user ID. What these functions will do is they are going to return you the IDs, some number, some integer number of the calling process. Which process is calling this function? That particular process number is going to be gets generated. Remember, that is why we use the word calling process. Returns the process ID of the calling process. And also in the previous class we have discussed this fork function. This fork function is nothing but which creates a new process. A fork function which creates a new process. For what reason this is required? Many of the time, example in the network, in the internet, there will be a server. Assume that at some location there will be a server. from so many different locations, from thousand locations, we are going to access some data from the server. From thousand users will access some data. In that situation, what happens is there is only one software, one server at some location. Now, what that software or the program or that process will do is it will create a process, a child process. It will create a child process. Those child process will start servicing the request from the different locations. A single process cannot do all the work. Since so many in the network situation, so many uh, requests will come from different locations. For that reason, what we do is, in order to do simultaneously, the process will create a new process, which is called as a child process. In order to create that, we use the function called fork. This logic will inbuilt we are going to write. Whenever the request comes, call the fork function. It will create a new process. In that way, it happens. If there is only one way, there is a only way to create a new process created by the Unix kernel when the existing process calls the fork function with this fork. The return type, the type of that is PID underscore T. This is inside the header file called unistd.h. And also I have discussed that whenever the new process gets created, what are all the things that is being given to the new process? What are all the functions? What all the data is being given to the new function is it is the entire the parent copy will be given to the child, like the data, heap, the stack segment, everything. Those memory will get a separate copy for the child also. Whatever the content was there with the child, it will be there with the uh, parent. That will be there with the child. That is why child is a copy of the parent. But what the child process will not get is the code segment. The code segment is needs to be shared. The entire code segment it will be shared by the parent and the child. But the data, heap, and the stack, the address space, all the things that will get a separate copy. Child has a separate copy. Parent has a separate copy. In order to demonstrate, we have shown one example. Wait, whether will try it in the system, whether it will execute. Or so many other libraries are required to run this program. That is why it is not able to understand the standard out underscore file number. If we comment what happens, we'll check it once again. Okay, execute now. This is what the output that I have shown in the previous class, how it gives the number. See, this is some PID, process ID that it gets generated, and these are these two variables gets incremented. But how the parent's copy will not change, all those things that we have discussed. Now we'll go to the file share. That is the topic that we have to discuss today. See, uh, all the things what the parent will get, parent has, everything will be given to the child. That we already know. But the file sharing, whenever the parent and the child, if they try to access some file, whether the file and the child, whether will they'll get a two different copies, that is the thing we have to discuss now. See, the fork will create a duplicate copy of the file descriptors opened by the parent. Assume that a parent is accessing some file. What is the control that the parent has on that file is file descriptor. That is one number. That is some integer. That number, that is an unique identifier of that file. That is called as a file descriptor. Any file, that file control, how it will be identified is uh, that pointer, that is called as a file descriptor. The parent process will holds that file descriptor because it has to do some action. It has to write something, some message. I like something. It has to write. The process has to write some message to that file. That is why it has some file descriptor. Open. But at the same time, the parent process has created a child process. Whenever it has created a child process, it will not create a separate file for that. A duplicate copy of the file descriptor also be created by the fork. Means that control over that file is being given to the child also. Now the parent and the child both have the file descriptor. If they both have the file descriptor means then nothing but any parent or the child can write or do any actions on that file. They have both the controls. The question is how the descriptors has been handled after the fork. How the descriptors, file descriptors, that controls will be handled. In two ways it will be handled after the fork. Handle is nothing but parent has to write something. In the same way, child has to write something to that file. But how it will be handled is, what the parent will do is, parent will wait until the child to complete. Child has a file descriptor. It will start writing the content into that file. It will complete. Once it is complete, the parent will starts. It will update accordingly. Child will first complete. After that, uh, the parent will complete. That is one way of handling the descriptor. The another way of handling the descriptor is parent will do its actions, the child will do its own actions. Both will not wait. That is another way. The parent will close the descriptors that it does not require. In the same way, child also, whether the descriptors, if it is not required, it is going to close. That is another way of handling the descriptor. Still, this if you do in this way, there are still some problems exist. This is how the file is being handled by the both the parent and the child. What all the things which are being inherited beside the open file, the other properties inherited by the child from the parents are these things. Inherited is nothing but they are going to get it from the parent process. All these things, real user ID, group ID, effective user ID, effective group ID, all those numbers, if you check in the parent and in the child, it is same. Supplementary group ID, process group ID, session ID, All these informations, everything, it will be same in both the child and in the parent. All these things are being inherited from the parent by the child. Then we should know what are the main difference between the parent and the child. What if you check the parent and the child? What will be different values in the system? If you check in the parent and the child, first the return value of the fork for child it will be zero. For a parent it will be any other number, non-zero. Process ID if you check for parent and child, 100% it will be different. Parent process ID, that ID will be different. The values of some other time related informations, all these things for the child it will be zero. Yes, 19 CS 410 has raised the hand. What is any doubt? 19 CS 410. No doubts. Then all the file locks, the file, uh, the parent process or any other process will have the lock over the files, whether to open or not. All those file locks which are set by the parent, it will not be inherited for the child. Is there any signals? All the set of pending signals for the child that will be set to the empty set. The pending alarms which are going to alert the other process, all those that will be cleared by the child. These things will be different from parent and the child. These things will be different between the parent and the child. Finally, what are the main uses of this fork function is? The main uses of the fork function is in order to execute the different sections of the code. Now to execute different section of the code at the same time, what the process will do is process will create a child and both will execute different sections of code. If we to do like that, the execution is faster. That is the main use of the fork. The another use is if the process wants to execute a different program, another program other than this, but this process has to execute. In that situation, what it do is going to do is it will create a new process. The parent process will execute the source one, and the child process will execute the another different program. For these two reasons, the fork function will be used. In the same way, the fork, there is another function called vfork. There is one more function called vfork. What What the different is there in this V fork is the functionality of the fork and V fork is almost the same. Functionality, whether fork will create a process, yes, it will create a child process. In the same way, even the V fork also will create uh, the new process. But what is the main difference here is the child will run in one same address space of the parent. It will run in the same address space of the parent. It will not get a new address space. Until what time it will run is the child process until it calls the exit function or execute function. Until that time, it will use the same address space of the child. Because of this reason, the V fork guarantees that until the child should first execute, after that the parents gets execute. How it will come to know whether the child has complete the work is The child, once it does all the work, it will call the execute function or the exit function. That indicates that the child has completed its work. If because the execution of the process always it will be asynchronous. The parent process is going to execute some program. Simultaneously, the child process will execute another program. They are asynchronous. We don't know when it is going to terminate. That is why, in order to synchronize, what we do is first we will make the child to complete first all his work. In order to do that, you have to use V fork to create a new process. If you don't use this V fork, instead of that, if you use fork, that synchronization will not be there. The parent process will execute subsection, the child process parallelly it is going to execute. There will be no synchronization. That is the job of this V fork compared to the fork. For that reason, in order to demonstrate, we have an example. See, instead of fork, we have used the V fork. If this V fork, if it is always we know it is always a positive non-zero integer, the PID. That is why if it is less than 0, this is an error. Two variables are there. One global variable, some number, any number you can write 6. Another local variable 88. Else, if any error, leave it. Or else, if the process ID equals to 0, if the return value of that is 0, it indicates it is a child process. If it is a child process, say we are incrementing two variables, that's all. It is just for the demonstration purpose. Two variables we have incremented, global plus plus and variable plus plus. The job of the child is done. How we are going to inform? See, underscore exit function is used. When the underscore exit function is used, exit function or execute function if you use, it is going to indicate that child will terminate. After that, some variables we are printing. Whenever you execute this function, what the numbers it is going to print is some unique number. The global variable it is going to increment. The output will be 7, some number, unique number, process ID, some 1000 or 1200, any other number, 7 and 89. 7 and 89. This will be the output of the this printf. I'll show the whenever they have executed 29039, globally 7 and 89. See, only once the child is going to execute these statements. If we have not written complete logic of the parent, all these things it will be executed. All the variable increment, the exit function, it will inform that the child job is done. After that, a printf state. If you have not sent the attendance, please send. The next topic is the exit function. The exit function that we already know, we have seen this exit function. Which are the reasons? It can be written from the main, or it can be written from the by calling the exit function. When does the process get terminated? That is the main thing. One is at the end of the statement, there is a return statement. That is why it is a normal termination. You have called the exit function. Whenever you call this exit function, what happens is it is going to call the at exit function. With the at exit, which are the functions which has been registered, those functions will be called They are called as exit handlers. That we used to call it as a cleanup processing. Whenever that is the main difference between this exit and underscore exit. Whenever you call this underscore exit, it is not going to do any function. Directly, it is going to terminate the program. But whenever you use this call exit function, it will check for the exit handlers and then it will execute all those logic and then it will terminate. This is what normal way of termination. The abnormal termination is in the system, there is a function called signal abort. You can send the signals. You can send the signals. Signal is just one information with some number. That number will come to the process. The process will decide what action it has to do for that signal. That is what the signal meaning. Whenever it receives the signal, the system will do some actions, whether to terminate or whether to leave as it is. That is the another way of termination. What does this exit status will do? We have used the dollar question mark, I think. You remember the dollar question mark. The dollar question mark will give you the exit status of the previous command. This same thing, whenever the exit status is used, that will be used to notify the parent how the child is terminated. If the child, if the child terminates before the parent, before the parent, the child gets terminated, but the parent wants to know what is the termination status of that child process. If it wants to get that information, it has to go for the function called wait function. What is this wait? What is this wait PID? What is the main difference between that? That we are going to discuss in the next class. But if the parent is not worried about the child which gets terminated, means it is not, the meaning of that is it is not executing the wait function. If that is the case, then that is called as a zombie. If the parent, the process gets terminated, the child gets terminated, but the parent is not yet waited for it. It has not waited for it. Then it is called as a zombie. What is this wait function? What are this wait PID? All these things that we are going to discuss in the next class. I think we have less than the 1 minute. This wait and wait PID is for just to get information of the termination of the child process. That we'll discuss it in the next class. Thank you. If you have sent the attendance, you can exit.